Welcome everyone from wherever you are calling in or watching in from around the world to this panel session, from hydrocarbons to heat, technology transfer, development, acceleration, and scale. My name is Rebecca Schulz. I am a consultant at the International Energy Agency, and I will be your moderator for today's session. This session is special. This is part of a two-part series. The first session is today, focusing on heat technology between hydrocarbons and the geothermal industry. And to introduce this session, we will start with a short preview of a report currently in peer review titled The Future of Geothermal in Texas. This report is over 400 pages, but for today, we will just focus on a sneak peek, a preview of one chapter of the report, the potential for the oil and gas industry to accelerate geothermal deployment. Before I dive in, I would like to thank and recognize my co-author for the report in this chapter, Dr. Silvio Leviscu with the University of Texas at Austin. I do invite you to join us tomorrow as we go into the second part of this series, as tomorrow's panel focuses on taking these learnings that our panelists will talk about today and how do we expand those into the techno-economic case for geothermal. The scope of the paper covers the major geothermal technologies that focus on heat and power generation, looking across direct heating and cooling, focusing on the transfer of heat to support residential and light industry needs. Conventional hydrothermal, this is the classic geothermal technology that focuses on fluid and mass exchange to produce power, electricity, and often is found near tectonic plate boundaries or in volcanic basins that have high permeability and high heat flow. The third technology we focused on was enhanced geothermal, where we utilize injection and production in the subsurface in very, very deep, very tight rock to generate power. Permeability is created through hydraulic back fracturing quite often. And in EGS, we have mass and fluid exchange between the surface and the subsurface to generate power. The fourth sector of technologies are really closed loop systems or hybrid closed loop systems. These are also called advanced geothermal. And in these, we use these to generate power, but there is no direct fluid or mass exchange in the subsurface. And in this paper, we examined three major questions. One of these was what really needs to be in place or proven to move these technologies to scale. The second is, what are the primary learning transfer levers and by how much and when could this transfer happen? How much could we drive down costs with further collaboration between the two industries? And what are the mechanisms of the transfer? How do we actually do it? And in particular, because we focus on Texas, what makes Texas subsurface, its people, assets, and resources unique for scaling geothermal? The first question we looked at is really one of the primary goals of this report, and that was to assess a technology roadmap across these geothermal technologies. And we found the following elements in common across all technologies and needed for successful deployment at scale. The first of this was really adequate heat transfer. Does the technology work in the field, and can we prove it out? The second is not just does it work, but does it work in the long term? Does it have sustained operability? Can we rely on it? The third is, does it have sufficient resource to scale? Can it move beyond a limited niche or area into a broader area, a broader swath of applicability? Can we move markets and grow the markets? Fourth, do we have and can we demonstrate a credible path to cost reductions? Can we get to competitive costs for power generation from geothermal? And then finally, is there a market? Do consumers know about their options? Do they want it? And can we help it to grow? And you'll be able to find these roadmap elements broken apart across the technologies when the paper is released later this year. The basis of this chapter and the basis of the analysis stem from technical research and dozens of interviews across industry, investors, researchers, and policy advisors. As the technologies are at different stages of maturity, we characterize these crossover learnings in three primary buckets. The first of these is direct oil and gas spillover. Essentially, what can happen today through collaboration and application of oil and gas industry ways of working, technologies, its people into the geothermal industry. And Utah Forge is a great example. The second are economies of scale. If the technologies can prove sufficient heat transfer and sustained long-term operability, if they have a sufficiently large resource base, how much can we drive down costs using advanced supply chains that can become increasingly connected in larger areas? And finally, in research and development, we broke this into two different sections. One are those technologies that are trialing now. So what could be put in place and trialed and put into the field within, say, the next 5 years? And also technologies that are on the benchtop today. So what needs to be in place, what needs to be funded now to be ready to move those trials and move the technology ahead into the field in 5 or 10 years' time? And using these categories, we assembled the types of learning and their time windows and applied this based on the feedback and the research that we did across the different technologies. Here we have a sneak peek at the results. And these are shown using with the levelized cost of or electricity on the y-axis. And on the bottom, for each technology type, you can see the learning type that goes across and what the range of learning of learnings can be, and also their midpoints. And to sum it up, the range of learnings really depend on the technology, its maturity, the type of learnings that are applicable in that technology. And so on a low case, we see that we can decrease costs by about 20%. Essentially, if we step our toes into geothermal, if we kind of do the basics, we can drive about 20% cost reduction. With further integration, with really bridging across the two technology or across the two industries, we see that we have about a 60% cost reduction with a much more integrated approach that's going from how do we transfer learnings, how do we build economies of scale, but also how do we fund and get demonstration projects out into the field? But a major question that we have, and this is what I'd like to talk about with our panelists today, is how do we actually do this? What are the key mechanisms that we can do to understand where we see the opportunities and how do we put the opportunities in place to help see this transfer? One of those, we believe, is early adoption of industry practices. So how do we support projects and hire expertise from across the industries? How do we put these in place? The second is really providing funding and direct resource support for the entrepreneurs, for the companies, for the demonstration trials, for those that are doing R&D. The third swath we see is expanding geothermal into sedimentary basins. How do we really grow the supply and the resource base for geothermal? And finally, we saw providing industry standards and best practices. If you look across the oil and gas industry, we see that there are standards and practices put in place in North America, in Asia, in Europe, but on the whole, these are actually quite common as you move across some different areas. Is there something similar that can be done in geothermal that can help companies and industry providers, technology providers, move across between countries or between continents to help to open up their own market base and to help them drive down costs even further? And so these are 4 that we put out there, but I'm going to invite my panelists on in just a moment to help debate these and some of the other findings that we have in the report and to understand what their learnings are from their own respective positions. And so with this, we're going to take a very short break and we're going to bring on our panelists and come back to you in just a moment. Thanks everyone and welcome back. It is my absolute pleasure to be able to introduce to you our 4 panelists for our session today, from hydrocarbons to heat, technology transfer, development, acceleration, and scale. Going in a very democratic order, alphabetically by first name, I would like to introduce my good friend Dragutin Domitrovic. Drago is the CEO of Calida Aqua. So Drago, please, I hand it over to you. Introduce yourself, tell us about yourself and your role in geothermal.
Thank you so much. So Calida Aqua is a one-man band, so you see the whole company in front of you. And I started being a geothermal consultant 2.5 years ago, after being in geothermal industry for about 4 years. I was the head of construction and start of operation of the first and so far only geothermal power plant in Croatia, where I come from. And before this, I was for 23 and a half years in oil business. This is where I started as a petroleum engineer in oil company. So with this background and moving from the dark side to the green or the light, good side several years ago, yeah, this is where I am now. Thank you.
Drag, I'm so glad you could join us today. And I'm glad you moved to the light side of the force. Next, it is my pleasure to introduce Dr. Gioia Falcone. Gioia is the Chair of Energy Engineering at the University of Glasgow. Gioia, please introduce yourself and tell us what you do in geothermal.
Thanks, Becky, and hi, everyone. Yes, I'm Gioia, and I'm Ranking Chair of Energy Engineering at the University of Glasgow, where I'm also the head of the Energy and Sustainability Research Group, and I'm Associate Director of the Center for Sustainable Solutions. Like Drago, I also have a background in petroleum engineering. I then migrated into geothermal engineering and subsequently into the broader spectrum of energy engineering problems. And my specific interest in the field of geothermal energy is really about converting geothermal potential into actual geothermal resources and reserves. So translating potential into production of electricity, heat, and also cooling, and looking at the long-term sustainability of these resources, which Becky, you touched upon earlier on. And I really look forward to the conversation today. Thank you.
Thanks, Gioia. Next, it's my honor to introduce Junichi Sugiura. Junichi is the VP of Sanvean Technologies. Junichi, please tell us about yourself and what you do in geothermal.
Okay, yeah, my name is Junichi Sugiura, and I'm based in the UK. As introduced, I'm the Vice President of Sanvean Technologies. And in 2021, last year, so Sanvean Technologies, its sister company, Scout Downhole, and the parent company, Curve Drill Industries, have been involved in drilling Utah Forge 16A 7832. This is the injection well in EGS. And this is the first highly deviated geothermal well by Forge, including 5,300 feet of a tangent section at the inclination of 65 degrees. So the well ultimately reached true vertical depth of 8,559 feet and a total measured depth of 10,987 feet. So this was a really, oil and gas drilling optimization technologies were successfully applied to drilling geothermal well. And it has been documented in SPE 205965. So this was my involvement with geothermal drilling. And I'm really excited to see more of these wells. Again, my background is actually oil and gas. But I think, looking around, more of the subject matter experts from oil and gas drilling are involved in geothermal drilling. And in the future, I'm really looking forward to see more of these cases and stimulating more geothermal drilling activities, transferring, technologies and knowledge between, from geothermal to oil and gas and vice versa as well.
Thanks, Junichi. And our fourth panelist, the esteemed Pejman Shoeibi Omrani. He's a senior scientist with TNO. So Pejman, please, can you introduce yourself and tell us what you do at TNO and your interest in geothermal?
Sure. Yeah. Thanks, Rebecca, for the introduction. As said, my name is Pejman Shoeibi Omrani, not the easiest name. And I'm currently working as a senior scientist in TNO. For those who are not familiar, TNO is the Research Institute for Applied Sciences, and I'm working in the unit called Energy Transition. And within our unit, with 700 experts that we have, we are looking into different commodities, different ways to actually take Netherlands society through this energy transition by innovation and by technology developments. No surprise, my background was also in the oil and gas. I've been quite involved, I should say, till 2016, maybe 100% of my time was with oil and gas, and at this stage, probably less than 5%. I'm mainly working into two topics, or let's say, I'm passionate about two topics. One of them is optimizing energy systems, And the second topic is digitalizing energy systems. And I think these two topics land perfectly in geothermal energy. So I think I found the right spot for myself to develop. And I'm very happy to be part of this panel. I hope I can have a good contribution to the discussions.
Thanks, Pejman. And you touch on a place that I want to come back to a little bit later. And because the report that we discussed or that we shared at the very beginning really highlighted the exchange of technology between the oil and gas industry and geothermal. But something I want to come back to a little bit more towards the end is what are the other industries and technologies that we see are, the other big levers outside of geothermal. So hold on to that thought. And I'd like to start, if I may, and first to welcome all of you here and to thank you for joining me. Where I'd like to start is maybe building off of what Junichi had mentioned. So Junichi, you've given us the example of Utah Forge, and that has fast become, I would say, a classic example of what the two industries can do together. I'm curious to hear as well from Drago, Gioia, and Pejman, what do you see as you expand outside of just the drilling side of this? What are the big levers that you see that the oil and gas industry can help, let's say, accelerate or scale geothermal? What are the levers that you see? Drago, may I start with you first?
Sure. Maybe on the other hand, maybe I'm not the best example or the best person to start with, because with very strong roots in oil and gas, I have to say that, for example, Croatia is an example of a country which had not significant in a global sense, but for domestic consumption, quite a significant and quite a lengthy history of oil and gas production. And no significant or not real development of geothermal business until very recently. So what we have is a situation that everybody who does any geothermal right now in Croatia is essentially an oil and gas person, with very strong roots. So for me, it's always a pleasure to hear the different, somewhere around the world, differences between geothermal business and oil and gas business, because here in Croatia, it's absolutely the same. So, I mean, from day one, you have to keep in mind that in Pannonian Basin, where Croatia has the continental part of it, is in Pannonian Basin, which has very high geothermal gradient. For us, normal temperature in oil and gas reservoirs that we would be producing is between 120 and 180 degrees Celsius. So we were always, in a way, geothermal. So utilizing petroleum business or petroleum technologies, we had it from day one. And I'm interested to hear, maybe there are other examples like this around the world.
I think that's a really interesting example of how essentially there's no split between the two. Oil and gas is worked into it and is learning as they go. Gioia, can I ask you? Do you want to jump in on that? You have some of the longest history in geothermal of this group of panelists. What do you see over the last decades? What do you see as being the key levers that we could still learn from or move towards?
Well, I can make an example with my own mini career. It actually all started for me in geothermal when I was in Texas, and I started in Texas in 2006. And I remember being proposed this idea of looking into geothermal energy, and me coming from Italy, of course, I'd heard about geothermal before, but never done any work on geothermal, even though I studied petroleum engineering initially in Italy. And so quite a few years later, in fact, more than a decade later, now we see more work being done in Texas itself and beyond. So yes, there are plenty of things in common, in my opinion. And one example could be the project concept. I think that both the petroleum engineering sector and the geothermal engineering sector share this need for the definition of a project from source to point of sale. And so you are not there to just look at the subsurface and decide whether the subsurface is beautiful or not, whether it is talking music to you or not, but it's about converting that potential into a product that ultimately goes to the market and makes an impact on society. And of course, with clean energy production, we try to contribute to sustainable development of society. And when I say project, that for me also entails the infrastructure, the availability of the infrastructure, in the same way that we've seen oil and gas projects struggling because the potential in the subsurface was there, but the infrastructure wasn't there. So we see the same in some geothermal projects where, again, you've got the potential given to you by nature. There are, in principle, technologies for bringing the potential to the surface. But once you're at the surface, if you haven't got the distribution infrastructure, you risk to see the project stranded. And that debottlenecking of some of the projects can take years. And this is where there are opportunities for partnerships, which is also something that the two sectors share as expertise and past experience.
Thanks, Gioia. So some great points, and a few that I'm going to bridge off of as we go a little further. But Pejman, can I ask you? You're coming a bit more from an operations and chemistry background, if I recall correctly. Can you highlight what your observations are?
Sure. So I fully agree with the previous panelists. Well, that was very formal with Gioia and Drago. That indeed there are lots of similarities. So if I want to go a little bit more from looking into it from the discipline point of view, you still have the reservoir engineering, you have your production technologies, production chemists. So all these sort of disciplines where in oil and gas we also call it production optimization, flow assurance. You would see it also coming back into geothermal, and I think there is a great deal of experience and knowledge that can be transferred from oil and gas, especially in the domain of the production and operation. And one of the observations we see in the Netherlands is that one of the biggest focus was on the investment, finding a right location, make sure that there is no white spot, that you make sure that you find the right aquifer and you can drill it in the most cost-effective manner. And indeed, if you look into the cost envelope of how much of these things are important, that's actually going to determine probably 90% of your whole cost. But you also have the other 10%, which is the operation and production. And if you don't take care of that part properly, if your production line is going to be closed by scaling, if your lines are going to leak because of corrosion, that 10% is going to kill the whole 100% of your business case. So this is the part which I think geothermal industry can also look into the oil and gas, how they have deal with this, looking into the broad portfolio of oil and gas operations across the world, and you would find some similarities. Needless to say that there are a lot of differences as well. So I think geothermal sector can learn a lot from oil and gas, but there are also really some, I should call it also white spots in terms of expertise that oil and gas has never been exposed to. And I think I will get back to that probably a little bit later during the panel.
That sounds, yeah, Pejman, those are great points. It makes me think of one of Drago's points that he was talking about earlier in terms of Croatia is not just a geothermal industry and an oil and gas industry, it's an oil and gas industry that grew into geothermal. And so I want to open this up to all of you, and Junichi, perhaps start with you. Where do you see that oil and gas are comfortable with in the space of geothermal, and where do we see that the oil and gas industry is not comfortable with? And Junichi, can I start with you?
Yes. So in terms of drilling, so oil and gas industries have great technologies. We have developed, especially in the U.S. and the shale revolution, we have developed downhole motor, very powerful downhole motor, and a very durable PDC bit. And those are, didn't occur overnight, but over 5 years, over 10 years of shale revolution, really pushed the limits of all these equipment, and now it works at very harsh environment and became cost effective as well, durable and cost effective. So geothermal industry can take all these latest and greatest technologies and use it for a cost effective way to drill geothermal wells. Again, these are comfortable zones. I would say downhole temperature up to 150 and 175. So this is like oil and gas standard, and especially below 50, around 150 degrees C. You can find nice, good BHA, bottom hole assemblies, drill bits, and everything in a very cost-effective manner. And you can drill in a cost-effective way. And once you go to 175, reliability goes down, and then price, price range, will step up. And above that, this is where, above 175 degrees, this would be probably, more difficult for oil and gas industries to supply, best cost-effective solutions. But I think this is standard for any industries. I think oil and gas has the best equipment to cost-effectively drill geothermal wells. This is very interesting. So, for example, polycrystalline diamond compact bit, PDC drill bit. This was funded by, the commercialization of PDC bit was funded by U.S. DOE, Department of Energy, in 80s. And they pushed this technology to drill geothermal wells. And actually, oil and gas industry took over. And over the next few decades, technologies evolved. And nowadays, from comparing 90s, we are drilling more than 90% of wells with a PDC drill bit. And key to success to drilling a forge well very efficiently and with a higher rate of penetration is the use of a PDC drill bit. And actually, this came from geothermal research in a couple of decades ago and matured in oil and gas drilling industry, and then back to geothermal. So in the first geothermal highly deviated well that the forge drilled, this is 16A 7832. So they used the PDC drill bit, and the rate of penetration was 40 feet per hour versus previous well drilled with a conventional rock bit was around the 10 feet per hour.
Amazing.
Yeah, so this is amazing. Of course, and after that, Fred Dupree from Texas A&M and there are other researchers, took over and drilled 2 other wells. And they actually doubled, tripled the rate of penetration, drilling speed, and the durability of a drill bit drilling section up to 100 feet, 200 feet per hour. So this is something unthinkable, really, before the forge project. So I would say any government funding project will help the industry to move the technology forward and bring the cost down. So I'm sorry. This is a long.
So Junichi, I'm going to stop you right there because I want to open it up to Gioia and Drago and Pejman to jump in on the question of where do they see that the oil and gas industry may be a bit more or a bit less comfortable moving into. So Junichi talked about some of the higher temperatures above 175. What other angles do you see on that question?
Should I go next?
Go for it.
It's an interesting question. What do we mean by comfort? I think there is a technological comfort and an economic comfort. So I think if I start from the latter, one question for the oil and gas industry could be, where do I see a similar size of business to what I'm used to and the fastness of the return of investment? So that could be a way of defining comfort, as in translating your current business model and modus operandi from one application area to another application area. And of course, this is not always possible because we know that geothermal might take a little bit longer in terms of payback time, et cetera, et cetera. The other comfort area could be the technological one. And an example of where we have experienced a bit of lack of alignment for good reasons is mine water, geothermal mine water, where, when you start to talk about relatively shallow, man-made mine workings, the oil and gas industry says, well, it's not really the place for me to bring deep geothermal drilling like the one that Junichi has just been talking about. And the oil and gas industry has recognized that the shallower drilling sector for water wells already exists and it is equally well established. And so that's an area where drilling from oil and gas would not necessarily or directly be applicable. So these are just examples of where I see comfort may be framed and when there might or might not be comfort. And of course, you already touched upon the difference between high temperature and maybe low temperature settings In geological terms, we could translate that into volcanic settings versus sedimentary settings, and inevitably the oil and gas sector has been more comfortable talking about and characterizing sedimentary settings. And I'll stop here to give room to the other.
That's great. Drago, Pejman, anything you want to add into that?
I mean, I've witnessed, being a consultant, right, and in geothermal, I've witnessed several teams of oil and gas companies coming in for the first time. But of course, this is something which will be surmountable in due time. And they sort of cannot get rid of the approach that you would take as a petroleum engineer or a petroleum geologist. You would think about the top of structure. You would think about getting away from fault lines. You would think about producing through tubing and all the things which are completely different in geothermal. But this is something which every team learns, and it takes a little bit of time to wrap their heads around the fact that it's a bit different. But yeah, I would agree with what Gioia said regarding I think the biggest issue for petroleum for companies is that simply the amount of energy being produced in unit of time is much smaller than in oil and gas, and it takes more time, more effort to produce it, and the return on investment is much slower. So this is something that has to be accepted by oil companies when they jump on the train of entering the geothermal business.
Thanks, Drago. Pejman, I think you wanted to add something as well.
Yeah, definitely. So I want to add actually on the point that the Gioia said. So indeed, I fully agree that the sedimentaries are much more comfortable, let's say, position for the oil and gas, because they have been very good in characterizing these sort of resources. And apart from characterization, of course, production from these reservoirs and operations of these systems are also much more, let's say, familiar area for oil and gas industry. Even if you look into the details of, let's say, those what we call it, at least in the Netherlands, the low enthalpy systems, and there would be also some areas which are quite still unknown, even for the oil and gas experience. Because I mean, if you see, I mean, most of our tools, most of our even simulation models that we are using have been tuned for hydrocarbons. So brine has never been, let's say, the thing, and now the brine is the thing, right? So we have to always make sure that if we are using any of the tools which has been adopted from oil and gas, it is validated for those conditions. And these are the steps that, of course, in a lot of horizon projects, geothermal projects, we are looking into this. And we do see that in some areas, you see a big discrepancy. So if we want to go in that area, if oil and gas would like to use the same tools, technologies, and even, let's say, I would go a little bit into details like the simulation models and toolboxes that they want to use. They have to ensure that this is really have been validated for those conditions. And one other thing which is also very important is the brine characterization. This is also pretty important and not the most familiar area, I think, for the oil and gas industry, as again, brine was never the main concern. And now you have to ensure that you keep the brine at the right condition to the surface. And that's going to determine your business case. So these are all technical things, but eventually you need to understand them, characterize them, being able to model them and understand how your system is going to behave in the next 30 to 40 years.
But not just brine, but also interaction between brine and dissolved gases, CO2 plus, whatever there is in there. Which is, I think, from my point of view, it's not very defined or described in many details at this point. Not that commercially available softwares.
And I think this is the part that actually oil and gas can directly bring technology to geothermal. Is the area that oil and gas knows how to deal with the gases, how to deal with the oils, and this is the part geothermal is less familiar with it. One last example I want to give is about the thermal storage. I think this is also the area which, at least what I see, the climate in the Netherlands, geothermal sector is much more experienced in storing heat at shallower reservoirs, but at much higher temperatures, how to do that. And this is the area which actually you can say transfer from geothermal to oil and gas for the ones who actually have the vision to come to this sector.
I think it's going to be a really, really interesting area to learn and grow into, and a lot of interesting, let's say, demonstration projects that are going around both in the subsurface, but also in Finland and other places in the surface. And I will just touch on a point that came across in the Q&A, that the report that we focused on was really power generation and heat. So we didn't touch a lot on brine and mineral extraction from brine, although I think that is a very, very interesting place with respect to critical minerals and how geothermal can contribute to the energy transition. And I want to, Pejman, I want to come back to you perhaps briefly to kick us off on this question of what are the other industries or technologies that are not necessarily oil and gas specific, but that we feel we could bring in as a larger geothermal industry and leverage and use even to greater degrees.
Yeah, sure. So one of the thing, I mean, at least one of the new trends is currently called shallow geothermal. So because if you can actually find the right reservoirs at much shallower depth, then more or less you're going to save a lot in terms of the drilling cost. And this will be actually something which currently in the Netherlands is getting pretty popular to really characterize and see what is the actual gain you can get from this. And in a project that we have done last year, we've also looked into the drilling practices from the water sector. And there you can also find that in some areas, maybe those technologies and those protocols could also be pretty applicable. And I'm not talking about the regulations and those sort of things. So purely technical part that I'm talking from, that is one area that you can learn around from it. And if you go also to the process sector, there is a lot of things about how you can filter waters, how you can treat waters. And I think the latest example of the mineral recoveries, you even see that there are actually companies expert in mineral recoveries who are now acquiring geothermal plants. So I think that's also an interesting aspect to look into it, that maybe geothermal would be actually also a mineral mine.
Absolutely. I think that's going to be a really interesting place in the future, and how countries can start to build some novel supply chains as well. Perhaps opening up to Drago, Gioia, and Junichi. And does anything top of mind when you think about other technologies that we could apply to geothermal that we haven't quite done yet, either from oil and gas or from outside of oil and gas? Gioia, I see you nodding. So,
well, I'm thinking hybridization of geothermal projects, so bringing in additional renewable components. For example, if I say solar, I'm thinking about how the oil and gas industry already implemented solar in solar EOR. Enhanced oil recovery, and we can think about doing exactly the same to boost some of the low to medium enthalpy resources before they get used, before they go into a power plant. So I think there are already opportunities to bring multiple renewable energy technologies within the same project. So I go back to the concept of project. And on this point about the extraction of precious minerals and metals, that's another thing that the oil and gas industry has been pretty good at doing in the past, by looking at non-hydrocarbon products that could be co-produced from the oil and gas projects. And then the technology that, as Pejman already mentioned, for extracting such minerals, assuming that we're going to be allowed to continue the idea of extracting lithium from geothermal brines, because as you probably know, the European Union is considering putting a ban on lithium because it's regarded as a reproductive toxin. And the UK has taken just 4 days ago a stance that it will continue supporting extraction of and production of lithium. But there is at the moment a big question mark that has halted investment in Europe. Thank you.
Interesting, Gioia. I hadn't heard that. Drago, Junichi, anything else you want to add in?
Yeah, I mean, we are talking about technology here mostly, but I think that the key question of how to scale up geothermal, actually right now, at least speaking from a local perspective here in Croatia, is really shortening and down and streamlining the permitting procedures. Again, speaking from local perspective, we have significant resources, up to 500 megawatt, maybe even 1,000 megawatt of geothermal electricity generation capacity here in Croatia, just in continental part of Croatia. The capital is there. People are ready to invest, but with the outcome of the perspective of having your power plant ready to produce between 5 and 8 years from the moment that you get the exploration permit is a little bit off-putting for many investors. And they say, okay, I mean, 8 years, Are you really sure about this? But yeah, the procedures are like this. And on the level of European Union, maybe this is not so familiar to people in the United States. On the level of European Union now, with the energy crisis, war in Ukraine, etc., there's a lot being done to push member states to speed up and to streamline the procedure. But there's still a lot of work to be done.
Thanks, Drago. And I want to switch and maybe ask Junichi if you can answer this one. I want to start to transfer us over to some more of the questions from the audience. One of the questions is really about how do we transfer these learnings? So the question is, oil and gas is usually more conservative regarding how the information is shared. So patents, confidentiality agreements. How can we build a foundation to collaborate? So what do you see as being those mechanisms that we can use to really collaborate and to move technology and learnings forward? And maybe just 1 minute each or so, or just a brief response so that we can grab a few more questions from the audience. Thanks, Junichi.
Yeah. Okay, yes. So Rebecca, you actually took the lead last year, and as a SPE, we launched a new geothermal section, technical section. Plus, we also held the first SPE geothermal workshop. So, I mean, this is a great way to connect, experts, subject matter experts inside the SPE to get together and then talk about, all the techniques and standardization, technology transfer, all the best practices. And on top of this, I mean, we should be able to collaborate with IADC and some other companies, of course, in the geothermal organization as well. So I think now we are moving right direction, having some technical sections and organizations representing geothermal, even within SPE and oil and gas industry. So I think this is a really positive move. Industry organizations are a big lever. They are. Pejman, Gioia, Drago, any other key mechanisms or levers or ways that you see that we can start moving things forward a little faster, be it the regulatory side, be it the technology side?
Yeah, go ahead.
So no, I have a bit of, let's say, I want to kind of looking into the question that oil and gas is a conservative industry. I've worked in also for different industries, especially from a digitalization angle. In principle, all industries are conservative. So I think that's not, let's say, the kind of a limiting factor here. I think it's really the mutual added value that these two sectors can bring to each other. That is going to be the driver. So if oil and gas doesn't see an added value in geothermal, there's not going to be any, let's say, willingness to do that, right? So, and I see that's not the case. I mean, last year we just actually published a paper together with the biggest geothermal operators in the Netherlands and Shell to look into, for instance, geothermal pumping. What can you learn from oil and gas industry? What geothermal can benefit from this? What are the gaps? So I think that is the part that if these two sectors see the willingness to work together, or if you see an oil and gas industry which wants to, let's say, go into the geothermal area, then that comes really automatic. So,
good example.
Yeah.
But I would say that also it's quite important to spread the awareness of geothermal opportunities and potential, not just within industry, but also much wider. General public, politicians, powers that be, so that you don't have resistance in those circles, and then you can move it much faster.
And I can stress that indeed, in that we've also moved from the protocols for social acceptance that the oil and gas industry had to, in a way, face first as one of the first sectors. And we moved away from the social acceptance to actually empowering the energy citizens. So having events, platforms, fora that can facilitate this one-to-one equal level dialogue between the so-called operators and the communities. And we need to understand that in the geothermal sector, we probably don't have such a clear old-fashioned way of defining an operator. For example, for thermal energy storage projects, if you want to connect to the district heating and cooling network, who should then be the operator of the boreholes? Who should be the operators of the subsurface? Probably we will see moving forward district heating and cooling companies themselves becoming also the operators of the boreholes. And Becky, I can only echo the need, I think, for data access and making sure that we are not losing access to strategically important data that the oil and gas industry acquired over the years worldwide. And so I'm talking about cores, I'm talking about fluid samples, I'm talking about pressure measurements, temperature measurements, records of how the boreholes were drilled, about completions, about production data. And this is unfortunately in some countries rather scattered information, and there is a very, very strong risk that information really disappears if an operator leaves a certain country, if an operator goes bankrupt. And we have to face reality, but act early and perhaps start connecting also geological surveys across Europe, across the world, making sure that they become the custodians of transparently accessible information. And there is a danger of also having some services being purely commercial. Data access is becoming a bit of a commercial area too, and this is potentially not the right way to go, at least in my opinion. But then accessing free access needs to be subsidized by someone. It's not going to happen otherwise.
Gioia, I think that's a really excellent point. Sorry, Drago, go ahead.
Maybe it's wishful thinking on my part, but it would be fantastic if we could sort of stimulate people to share their failures as well, not just successes. Because this is a fantastic way to learn. And we haven't seen much of this in oil industry, not that I can recall. Not many companies are willing to share their failures. And if we could make it different this time, it would be fantastic.
And heating water was not something you would want to normally share, was it?
Yeah, of course.
And also, Becky, maybe also just wanting to go back to the slides that you show. I think on the part in standards, I think oil and gas could also bring a lot. What we see, it's really lacking in geothermal, and oil and gas have been very successful in this. Still, I think in the geothermal sector, a lot of API standards are being used. So I think maybe we should think of maybe AGI or even international geothermal institutes to come up with some standards, but I think that is the part that geothermal sector can learn a lot from the petroleum sector.
Sure.
I echo that as well, because I think you can really see just the ability for markets to grow and for companies, whether they're larger or small on the oil field service side, say the Schlumbergers, the Bakers, the Halliburtons of the world. They can move between countries because industry standards are more or less the same. So it allows them to really work their inventory and their staff in a very efficient way. Whereas from a geothermal sector, we see that it's much more regional. And the standards are, if they're in place, are very, very localized as well. I think that's a great point. And Gioia and Drago and Junichi, all excellent points. We have about 5 minutes remaining. And so what I'm going to do with the last 5 minutes is I'm going to hand it to each one of you to perhaps leave the viewers of Pivot 2022 with your final thoughts before we wrap up and have to say farewell to the panel. And so with that, perhaps, Gioia, if I can, may I hand it back over to you for maybe just 1 minute to give your final thoughts on how to really move geothermal technology and deployment to scale by say 2030. What do you see?
Thanks, Becky. And actually, I was about to bring time into the discussion because I think it is important that we work across sectors to really develop a tangible roadmap. So we need to start becoming really realistic and transparent with identification of the geothermal projects that are really likely to come on stream by year X. We cannot just project everything into the future. We need to really be clear about what is the development, what is still R&D, and what is still pure R. And there is also inevitably an issue of funding, investment, incentives that vary depending on whether you are a D, an R&D, or an R. And I think we need to be courageous and be really transparent and say, well, this is probably analogous to fusion in nuclear. We know we want to do more fundamental research. There's obviously potential, but the majority of the people will agree that probably fusion is not going to kick in until after 2050 if we can prove it can work. So we might want to apply a similar logic to geothermal and be really realistic and probably identify the low-hanging fruit that is low risk, perhaps low revenue, but can also help us in gaining more and more confidence in geothermal. Thank you.
Thanks, Gioia. Junichi, 1 minute, your final thoughts?
Yes, so what get me involved in the geothermal is actually U.S. Department of Energy Forge project, and DOE continue to fund, those geothermal research and demonstration projects. So I think this is really an excellent way to move the technology and wider audience move forward. And I continue to involved in this kind of a DOE funded project. And now what I'm started seeing is more of the traditional oil and gas companies, not major companies, but also medium size, getting into geothermal because of this DOE stimulated funded project.
Government,
yes,
very
and,
important.
Yeah, and of course somebody mentioned there's a concern about the data disappearing. So the Forge project, everything is really publicized. All the data is archived and publicized, and we even have datathon based on Forge project data coming next session. So I think this is an excellent way for encourage oil and gas people to engage in geothermal and moving forward this industry.
Thanks, Junichi. 2 minutes left. 2 excellent panelists. Pejman, can I hand it to you to give us 1 minute of your final thoughts?
Sure. So I think back to the question of by 2030, how we can make things fast. I think cost reduction. Cost reduction will be key if we want to achieve something within the next 7 to 8 years. And cost reduction doesn't mean let's go cheap. No, it means, of course, going for the technologies, for the equipment that can last for a longer time, and you're going to save a lot. But also, time is also cost. So the permitting part that Drago said, I fully agree on that. We can save a lot on this. And I always think that I'm really lucky that I'm living in this era, that I'm going to see what's going to happen by 2030.
Thanks, Pejman. And I think building on what Gioia said in terms of sharing the data, building on what Drago said in terms of also sharing our learnings and our failures, which is critically important. So if we can speed that up through a more streamlined regulatory process, it's critical. Drago, I'm going to hand it over to you for the final thoughts to help close the panel.
Oh, yeah. So I will be very concise. For all the petroleum engineers and petroleum geologists and all the petroleum people who are sitting in the audience, I made my move from oil business to the geothermal business. You can move it. You can move as well. You can do this. And I believe that the future of petroleum business is hot and wet.
Thanks, Drago. And thanks to everyone for joining us today. Have a great afternoon, morning, or evening, wherever you are.